So we started on the left-hand side because this was more complicated than this. We found the least common denominator, which is the product of these two. As I mentioned, I normally say, do not multiply, do not expand the denominator. In this case, it was necessary, eventually anyway, because we replaced this by cosine squared from the basic trig identity. So this has three terms, 1 plus 2 sine theta plus sine squared. This has the same three terms with minus in front, but there is a minus. So minus plus minus, minus plus minus. So I didn't mean to cross out the 2 sine theta plus 2 sine theta. These are both positive. So they stay, but everything else goes away. How come? Well, positive sine squared with negative sine squared, positive 1 with negative 1, and 2 plus 2 is 4. So we have 4 sine theta from the top and cosine squared in the denominator. When we separate, 4 sine over cosine times 1 over cosine, so this is rewritten as 4 sine theta over cosine theta times 1 over cosine theta. 4 sine theta, cosine squared. This is changed into tangent, and this is changed into secant. And 4 stays up front. Anything else you would like to go back to, or we go back to our list? You want to go back to anything from the test? Are these steps clear, everyone? Yes? No?
Yes.
Okay, good. So let's go back. Next question. Do you have other questions from the test? Or we move on to anything here?
You do a reducing powers.
Yes. Do you want to choose one? That is a very important type of question, mainly for Calc 2, I have to be honest. Would you like to pick one?
We just do the one from the test.
Yeah, I think we did that in class. The exact same one. Cosine to the 4th. Yeah, it should have been in your notes. So let's do that. So cosine x to the 4th power is the same with cosine squared, everything squared. And this we have a very important formula to replace. It's 1 plus cosine 2x over 2. But now I have to square that. So this is a huge formula. It is very important for Calc 2. Very important. Not as much for Calc 1. Okay, so then I have 1/4 in front, and I have to square a binomial. By the binomial theorem, how many terms do I have to get?
Two.
Always 1 more than the power. Always 1 more than the power. So when we raise a binomial to the 4th power, we always get 5 terms. When we raise to power 2, we have to get 3 terms. When we raise to power 10, we have to get 11 terms. And those are 1 plus 2 cosine 2x plus cosine squared 2x. I distribute 1/4. 1/4 plus 1/2 cosine 2x plus 1/4. But I have to replace this again using the same formula, which is 1 plus cosine 4x over 2. It's done, but I have to rearrange it and simplify it. So 1/4 plus 1/2 cosine 2x. 1/4 times 1/2 is 1/8 plus 1/8 cosine 4x. 1/4 distributed to 1/2, and 1/4 distributed to cosine 4x over 2. I have to add these two. The least common denominator is 8, so I need 2 plus 1. So 3/8 plus 1/2 cosine 2x plus 1/8 cosine 4x. And this is it. We have to apply this very important formula twice. So cosine squared x is 1 plus cosine double angle over 2. Same thing here. Cosine squared 2x is 1 plus cosine double angle over 2. Same formula. Is this okay?
Yeah, that's good.
Perfect. Next question. What would you like to check next?
With that paper, please.
This should have been in our notes. I put the same problem from the notes, from the class notes. Next one. Or anything else. It doesn't have to be, maybe you want to look at something from the test again. Anyone? Let's choose the next topic, please. Anyone, please?
Can we do log equations?
Yes. Perfect. I'm going to open the handout or the book. It will take me a couple of minutes to make up a log equation, so I'd rather go to log equations. I'm trying to find a handout on logs. This was chapter 4. No, it wasn't chapter 4. What chapter was it? Radical equation by factoring, square root. Yes, here it is. You choose, or we can go to the book. I'm sharing my screen right now. So it was indeed chapter 4. So these are exponential, 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 exponential. Here are the logs. This is one, this is the other, this is the third, this is the fourth, this is the fifth. Here we have 5 different equations to look at. You choose.
Can we do 32?
Yes, 32, perfect. So let's look at 32. And we have log base a of x plus log base a of x minus 2 equals log base a of x plus 4. Something very important with logs. They are not friendly. Logs are not friendly. For the most part, they're not. What is the restriction or the condition for this? What does x have to be? The same thing for this. What does x minus 2 have to be? And the same for this, x plus 4. Anyone remembers? All these expressions must be
and 0.
Excellent. Excellent, thank you. And not equal. I know you didn't say that. Perfect. Everything you said was perfect. Not 0 or negative. Excellent. Good. So then I have 3 restrictions. Greater than 0, greater than 2, greater than -4. -4, +2, and 0. So let's graph just to see which one to pick. So here's the first one, greater than 0. Here's the next one, greater than 2. And here's the last one, greater than 3. I meant -4, of course. And we have to choose where all 3 colors exist, because all 3 conditions have to be fulfilled at the same time. So where will the solution be, or domain for this function? Where do we see all 3 colors? Black, orange, and blue. That's where the domain is. That's where the solution must be, or there is no solution. Is anyone courageous to say something?
Would it be 2 to infinity?
Absolutely. Thank you so much. 2 to infinity. Now, let's condense. How do we condense the left-hand side? Log x plus log x minus 2. Anyone remembers how to condense the left-hand side?
Actual log.
Excellent. I need something. I need something here.
You would multiply.
Very good. X squared minus 2x. Awesome. Since there is a sum of 2 logs, these quantities get multiplied. X squared minus 2x. Perfect. So now what has to happen? For log base a of this to be equal to log base a of this, what has to happen, without which it's not an equation, it's not a possibility. It's a contradiction. But we are told this equals this. What must happen for these 2 to be equal? What must happen for these 2 to be equal? Can log base a of 5, can log 5 equal log 10? Can log 8 equal log 15? So what has to happen for these to be the same? Give it a shot, please. It's the same base.
You would set x squared minus 2x equal to x plus 4.
Thank you very much. There is no other way. This is quadratic. Students, for some reason, forget that this is quadratic and they start simplifying by factoring and this and that. Please, it's quadratic. So x squared minus 3x minus 4. If you don't want to factor by grouping, or just simply factor, or use the quadratic formula, use the apps in the calculator and get the two solutions. Although this is too easy to do that, but it's okay, it's acceptable. Find the solutions with the apps and the polynomial root finder. So can anyone give us the factored form? It will take longer to put it in the calculator. Can anyone give us the factored form, please?
X minus 4, x plus 1.
Thank you very much. So the two options are
X equals 4 and x equals -1.
and the answer is not to so fast, right? I found the solutions. No, 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 no. I worked hard for this. So then what do we conclude? You muted yourself before we heard the answer, Kevin. You muted yourself again.
Sorry, x equals 4.
Of course. It's the only one that belongs here. That's why we work so hard. We know that this does not belong here. Good. Questions, please. Questions on the log equation. Okay, next topic.